These are notes from Melham's Math 70 for Friday, May the 1st, section 12.4, page 725. And remember, you also have a quiz today on previous material at 12.3 and 12.2, so make sure you leave yourself enough time to do the quiz. Due at 11:59 p.m. tonight, usual ruse. Do the work, take a picture on your cell phone, show all your work, and submit it to me by 11:59 p.m. tonight. Okay, today the big formula is to find the probability of A or B, and that's equal to the probability of A plus the probability of B minus the probability of A and B. And this is best illustrated with a Venn diagram. Remember, a long time ago, back when we were meeting face to face, we did Venn diagrams. Only now this is in the area of probabilities, so probabilities are between 0 and 1. Nevertheless, the picture still holds. You can see you can't just take the probability of A and add it to the probability of B, because this part right here would get double counted. So by the formula, you have to subtract the probability of A and B, that middle piece, otherwise it would be counted twice. All right, problem number 6. If you roll 2 dice, what's the probability of getting a 7 or an 8? So by formula, it's a probability of getting a 7 plus the probability of getting an 8, using this formula here, minus the probability of getting a 7 and an 8. But this is 0. When you roll 2 dice, you can't get a 7 and also an 8. So in this particular case, it's really just a probability of getting a 7 plus a probability of getting an 8. Which means in this particular picture, the A and the B are separated. They don't touch at all. You would imagine having one circle A, another circle B that don't touch. So then you can't just add the probabilities. Okay, so we've talked about this in the past. When you roll 2 dice, there are 36 possibilities, because you have 6 choices for the first die and 6 choices for the second die. 6 times 6 is 36. And how many ways can you get a 7? That's 6. So the probability of getting a 7 is 6 over 36. Here's all the ways that you can get a 7. 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1 for the first and second die. Again, designation of the first and second die is arbitrary. You can pick either one that you want. Now, the probability of getting an 8, we know there's 36 total. There's 5 ways that you can get an 8. 2, 6, 3, 5, 4, 4, 5, 3, or 6, 2. So the probability of getting a 7 or an 8, I just simply add the probabilities, because this comes out to be 0. So 6 over 36 plus 5 over 36, the answer is 11 out of 36. 9, I'm just going to use the formula directly, and they give us these values. So if you look at a problem number 9, they tell me that this is 0.9, this is 0.3, this is 0.8, and they ask you to figure this out. So it's just a simple plug-in. 0.9 equals 1.1 minus the probability of A and B. So this would have to be 0.2. So probability of A and B is simply 0.2. Problem 13 asks you to choose a number from 1 to 10 inclusive. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 possibilities. They want the probability of getting either an even number or a prime number. So that's the probability of getting an even plus the probability of getting a prime minus the probability of getting an even and a prime. That's the formula back up here. As usual, you don't have to memorize it, just look it up. So between 1 and 10, how many evens are there? There's 5. 2, 4, 6, 8, 10. So that's 5 out of 10. Probability of getting a prime is 4 out of 10. There are 4 primes, 2, 3, 5, and 7. And then I subtract the probability of having an even and a prime. So what number is even and prime? That's 2, so that's 1 out of 10. So 5 over 10 plus 4 over 10 minus 1 over 10 gives me 8 out of 10, which is 0.8. So the problem's finished, but just noticing, digging deeper, if I didn't subtract the probability of even and prime, then the number 2 would have gotten double counted, because there's a 2 here and there's a 2 also here, so it would have gotten double counted. So to avoid that double count, that's why in the formula you subtract the probability of A and B. Here's problem 15. Roll 2 dice. They want the probability of getting a 6 or doubles. So I just use the formula. It's probability of 6 plus the probability of doubles minus the probability of both 6 and doubles. All right, so the probability of getting a 6. So there are 5 ways to get a 6. 1, 5, 2, 4, 3, 3, 4, 2, or 5, 1. So that comes out to be 5 out of 36. Probability of getting doubles is 6 out of 36. Again, there are 36 total possibilities. There are 6 doubles, 1, 1, 2, 2, 3, 3, and so on, up to 6, 6. And what's the probability of getting a 6 and doubles? There's only one way. That's a 3 and a 3. That's doubles, and it adds up to 6. So 5 out of 36. plus 6 out of 36 minus 1 out of 36, so that's 10 out of 36, or 5 out of 18. 19, roll 2 dice. What's the probability of getting an odd or a number less than 6? So I figure out the probability of getting an odd plus the probability of getting less than 6 minus the probability of both odd and less than 6. Probability of getting an odd is 1/2. We saw that previously that the probability of getting an odd or an even number was 1/2 each. But if you want to see it again, probability of getting an odd, so here's all the odd possibilities, 3, 5, 7, 9, and 11. You could add that up. To get a 3 is 2 out of 36. To get a 5 is 4 out of 36. To get a 7 is 6 out of 36. 9 is 4 out of 36. And 11 is 2 out of 36. Add them all up, 18 out of 36, or 1/2. So the probability of rolling an odd is 1/2. Probability of getting a number less than 6. Well, that means you get a 2, 3, 4, or 5. Okay, again, you can work these out. Probability of getting a 2 is 1 out of 36. To get a 3 is 2 out of 36. To get a 4 is 3 out of 36. To get a 5 is 4 out of 36. That adds up to 10 out of 36. And finally, the probability of getting an odd and less than 6. So what numbers are odd and less than 6? That's a 3 and a 5. Probability of getting a 3 is 2 out of 36. Probability of getting a 5 is 4 out of 36. And that gives me 6 out of 36 total. Quickly, if you're not sure about that, how do you get a 3? There's 2 ways, either 1, 2, or 2, 1. How do you get a 5? Well, that would be 1, 4, 2, 3, 3, 2, or 4, 1. All right, so I just throw everything into the formula. Probability of getting an odd is 18 out of 36, or 1/2. And the second probability came out to be 10 out of 36, probability of less than 6. And then I subtract the probability of both odd and less than 6, 6 out of 36. That comes out to be 22 over 36, which is 11 over 18. And finally, 27, you need to use a chart, so I've copied and pasted this chart that's here. You can probably see it better in the text. So you've got age 0 to 17, 18 to 25, 26 to 34, and so on. And this way you have full-time, part-time, and unemployed in this particular survey. So they're asking for the probability that someone is 26 to 34 or part-time. So use this formula. It's a probability of 26 to 34 plus the probability of being a part-time minus the probability of both 26 to 34 and part-time. So to do this, first I have to find out the grand total in this experiment. So I add all 15 of these boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Add them all up, I get 3179. So that's my total in my sample space. So what's the total for 26 to 34? That's everything here. So I add across 348 plus 67 plus 27. That came out to be 442. And what's the total part-time? So this time I add down. So I add these 5 numbers for all the part-time. And that came out to be 775. All right, so the probability of being 26 to 34 is everything here divided by the grand total of 3179. So it's 442 out of 3179. Probability of part-time is 775, all of these, out of 3179. And the probability of being both 26 to 34 and part-time, well, that means just that one simple box there. So the intersection, right, intersection of these two is 67 out of 3179. So finally, the probability that I want of being 26 to 34 or part-time is the probability of being 26 to 34 is 442 out of 3179. And again, so 26 to 34, that's everything across here. Probability of part-time was 775 out of 3179, so I added all of these out of 3179. And I subtract the probability of 26 to 34 or part-time, 67 out of 3179, which comes out to be 1150 out of 3179. And I think you can see what's happening. If I add these numbers here, the 26 to 34, and I add the numbers here, all the part-times, well, this box 67 would have been counted twice. So to make sure it's only counted once, you have to subtract off the 67 out of 3179. So the answer for this one is 1150 over 3179. All right, so these are notes from Melham's Math 70, Friday, May the 1st. Hang in there a little longer, we're almost done. And make sure you do the quiz that's due tonight, Friday, May the 1st at 11:59 p.m. So we have section 12.5 coming up on Monday, and that will be the last section of Chapter 12, and in fact the last section of the entire course. And then the following Friday we'll have exam number 4.